Hello, today I am going to discuss about the PLC binary information representation. This is a basic and simple introduction for this topic. It's meant for beginner to understand about the PLC concept. Okay, so this is a example of the bits here. What is bits? Okay, maybe let me draw it. This is a bit. Bit can be 1 or can be 0. Okay, it can be appear as 0 or as 1. So 0 can be treated as off state. 1 can be treated as on states. Off also can be treated as clear, while on can be treated as set. Okay, so depending on the system, it can be 8 bits, 16 bits, 32 bits, even 64 bits, etc. Okay, so the rightmost corner bit is called least significant bit or LSB. Okay, and the leftmost bit is considered most significant bit or MSB. So here we have all the bits arranged side by side. Okay, so one nibble is equal to 4 bits. How I know? You can count from rightmost corner here. Okay, 1 bit, 2 bit, 3 bits, and 4 bits. So 1 nibble equal to 4 bits. 1 byte is equal to 2 nibble as shown here, which is also equal to 8 bits. Okay, how I know is 8 bits because you can count from here. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. Okay, for one word is equal to 2 byte. Okay, you can see here 2 byte, which is also equal to 4 nibbles. You can see from here, which is inside this frame. Okay, 4 nibble, which is also equal to 16 bits. How I know is 16 bits? How? You can count from rightmost corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's a 16 bits. Okay, so D word is equal to 2 word, which is also equal to 4 bytes, which is also equal to 8 nibble. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 8 nibbles, which is also equal to 32 bits. So the bits here is called bit 0. Okay, 0. Here is bit 1, bit 2, bit 3, and here is bit 31. Okay, the total bits here is 32 bits. Start from bit 0 until bit 31. Okay, so sometimes you may encounter the words called Q word. Q words, Q is stand for quad. Okay, quad means 4. All right, here D word, the D stand for double. One Q word is equal to 2 D word, which is also equal to 4 word, which is equal to 8 byte, which is also equal to 16 nibbles, and which is also equal to 64 bits. Okay, right, just hold on. Okay, so the first or the most significant bit for this 8-bit system is 2 power n, where this n stands for number of bits. Okay, for example, the first bit, which is the most significant bit, is 2 power 0, then followed by 2 power 1, followed by 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and then 2 power 7. Okay, so as we know, 2 power 0 equal to 1, 2 power 1 equal to 2, 2 power 2 equal to 4, and then this one is 8, this one 16, this one 32, this one is 64, this one is 128, right? Okay, so let's say the first bits is shown here. The first group of bits is shown here, which is 0, 0, 0, 0, 0, 0, 0, 0. Okay, so all 0 add up to equals to 0. So the decimal value is 0 for this group of bits. Okay, so let's say the next group is 1. So this one is this one, right? Decimal value 1. So 1 plus 0 is equal to 1. Okay, and then for the next group of bits, let's say it's a 1 0. So this 1 is equal to 2 decimal value. So this 2 decimal value plus a 0 here is equal to 2. Okay, so for the next example is, let's say the bits is 1 1. So this 1 equivalent to this 2 decimal value, and this 1 equivalent to this 1 decimal value. So 2 plus 1 plus 0 equal to 3. So let's say, how about this one? Let's say it's a 1 0 1. So this 1 equivalent to this 1 decimal value. Well, this 1 is equal to 4 decimal value. So 4 plus 1 is equal to 5. Okay, 5 decimal value. Now another example. Let's say is this one, 1 0 1 1 0. Okay, what is the equivalent decimal value for this group of number? Okay, this one equal to 16, right? And this one equal to 4, and this one equal to 2. So this 16 plus 4 plus 2 is equal to 22, and then so on. Okay, as for all these group of bits, which is 1 1 1 1 1 1, you add up all this number, you will get the equivalent decimal value of 255. Okay, let's say you want to calculate by using the calculator, you can do so. You can just type calculator in your search bar and open it. You click here and you select programmer. Okay, let's say for this number 1 1, you first select binary, then you click 1 1, then you get the corresponding decimal value 3. 1 1 is 3. Then how about this 1 0 1 1 0? So what you can do is you type 1 0 1 1 0. So you get about decimal number 22. Okay, 22, and so on. Another example, let's say I want to find the equivalent binary number based on decimal value. Maybe I have a value of maybe 89. So the corresponding equivalent binary number for this decimal value of 89 is 01011001. Okay, you also can use the same calculator to find out the equivalent binary value based on the given hexadecimal values. Okay, so in order to do so, you can click here hexadecimal here, and then let's say you want to find out maybe just an example, maybe uh 5 to C. So you can find out the corresponding binary number, which is 010100101100, and the equivalent decimal value for this hexadecimal value is 1324. Okay, sometimes you can see the big number 7 is used to represent sign. What is sign? Sign is actually a positive or negative value. Okay, for example, here you can see this bit number 7 is used to represent sign, which is a positive negative value. So 1 is used to represent negative value. 0 is used to represent positive values. Okay, for example, for this binary number, so the 1 which is equivalent to 3, okay, 3, and because the bit number 7 is 1 bit, okay, so this one at the bit number 7 is used to represent negative value, so the final value is negative 3. Okay, so that's it. Thank you.